So we're here to talk about the history of Hadoop in the History Museum, and looking forward from there. So today I'm going to talk about sort of the evolution of big data in 3 stages. First, kind of review the world before Hadoop, then talk about the impact that Hadoop had on the processing of big data, and then we'll look forward to where we are today and where we're going. So starting with traditional big data solutions, i.e. the world before Hadoop. So this talk is going to be very sort of web company centric. If this was a traditional data warehouse talk, you'd see more databases and more ETL in this diagram, but I think a lot of the learning and principles still apply. All right, so let's say you want to build a website. When you start out, it's a very simple architecture. You have a web server, maybe an app server. You have a database behind it that manages a lot of your content and context. And if you want to monitor that, it's pretty simple. You run some SQL queries on your database. So that's kind of how Yahoo started, how everything started. But as you scale up and scale up and scale up, you start to discover that there's limitations of that architecture. Right? It used to be great that you had all the data for your website in one database. And if you wanted to measure something, track something, you just created a new table and wrote some more data in your database. But what happens is over time, that monitoring, which used to seem free, becomes very, very expensive. We had some systems at Yahoo where when we did the analysis of it, we had some of the biggest Oracle RAC databases in the world, and 60-70% of them were being occupied doing sort of back-end analytics, reporting, stuff that was not related to delivering web pages to users. And that was a lot of money going to something other than what we bought the database for. And worse than that, you had the back office guys asking questions taking down the website, right? You don't want somebody trying to do sort of forward planning and taking down your service. So you move from everything in the one database to 2 distinct databases, an offline analytics database and your serving store. Lots of advantages to this, right? First and foremost, it really simplifies your operations, right? You take all those extra tables out, you take all that extra load out, you get more than half your database back, saves you a tremendous amount of money, and those analytics databases were much cheaper. So it reduces your cost. And finally, it allows you to have a built-for-purpose analytics database where you can do much deeper analysis, so huge wins. But it comes with some costs. First off, now you have another system you have to plan and build and maintain. So that adds a lot of complexity to your sort of total investment. It simplifies runtime, but you're spending more people, more time getting the whole system together. And it adds a lot of latency. Now you're waiting 12, 24, 48 hours to get information from your web serving, through your log systems, through your ETL, through your sort of cleaning, staging, preparing, to the point where it's in your warehouse and you can query it. So you're limited to sort of insight, not action, because there's just so much latency, right? You can learn a whole bunch of interesting, important stuff about your business, but the result tends to be, okay, give it to the product team, and when we do the next release of the website, we'll build an auto section because people are interested in automobiles on Yahoo, as an example. So lots of pressure to do more and do it faster and do it cheaper. And this is a lot of what gave rise to the pressures that gave rise to systems like Hadoop. So let's talk about the sort of batch processing era. So why Hadoop? So before Hadoop, we really had a scalability problem, right? We talked about how it was great to move all those tables out of the serving stores and into an analytics database. But when you're the size of Yahoo, that analytics database gets to be petabytes, and nobody's product scaled to petabytes. These things would run on 5, 10, 20 machines, and they thought that was big data. We wanted to run on thousands of machines. So Hadoop let you do that. You could just buy more nodes and add them, and the cost was very linear, right? You want to grow bigger, just add boxes. And that picture there is a single Hadoop cluster. It's actually a part of one of our major Hadoop clusters, right? So they got pretty big, 4,000 nodes that size, 4,000 computers. Reliability, all right? When you are building databases with 5 computers in them, the way you keep it from failing is by building really, really platinum-plated computers that never fail. You try anyway, and that works to some extent. But as you add more and more components, that just stops working. The components will fail. When you get to thousands of nodes, the systems that we ran before Hadoop, we analyzed and saw that those systems were down more than half the time, waiting for operator intervention to restore them to service. So Hadoop got rid of all that. Computers failed, the service just kept operating. The operators could go back and repair it at their leisure, the broken nodes, because the system was not broken. So the reliability was really hugely important. And the flexibility, all right? A lot of log data, media data of different sorts just didn't fit into traditional databases, or maybe it fit, but it kept evolving, and you don't want to be continuously changing your schemas on your database. Hadoop allowed much more flexibility, and really key to Hadoop's success, it was much, much, much less expensive at scale, because you could use commodity hardware instead of that platinum-plated hardware, and it was open source software, so you didn't have to pay the $10,000 a node or a core in licensing fees in some cases. All right. So that allowed a completely different kind of analytics architecture, where you took your logs into a system like Hadoop, and you did that regularly. You processed them regularly, maybe every hour, maybe every 5 minutes, produced actionable insight, facts that you could push back into the serving store and take action on. Let's look at an example. This is a page from a talk on how Hadoop impacted Yahoo. So what we did at Yahoo was we customized the front page of Yahoo so that it was built with content that we believed would be interesting to the users. Before Yahoo, maybe there was a little effort to do that with editorial work, but the question is, how do you know what interests all of the 250 million, 500 million users that are coming and visiting Yahoo? So what we did was we built some machine-learned classifiers that would look at the activity of users on the site and identify what interested them. If a user browses auto content, that's pretty easy. But we had thousands of different flags indicating interest in different things, and we would run all these classifiers and infer from a user's behavior what would interest them more. Maybe they're a global politics guy, global news, maybe they're into automobiles, maybe they're planning a vacation, maybe they want more stories about pets. So that's sort of what this engine would do, is it would take all of your actions every 5 minutes on the website, process it, infer your interests, push that back up into the serving store so that the next time after Hadoop ran that batch job that you visited Yahoo, the content would be more personalized to you. So what impact did this have? Right, this personalization for each visitor doesn't sound that complicated until you think about this as allowing the mass customization of the internet, right? We were doing this for everybody visiting Yahoo, which is a good fraction of everybody on the internet. What this did was doubled the time that people spent on Yahoo, right? Because they were finding more interesting content, they were following those links, they were reading those articles. They were even clicking on the ads more because the ads also were targeted at their interests. So this was a huge win-win. The users were spending twice as much time on Yahoo because they were getting a lot more value out of the Yahoo service. So good for the users. And Yahoo was serving a lot more ads and a lot more relevant ads, so very good for Yahoo and its shareholders as well. So huge win for everybody. And of course, Hadoop had impact well beyond Yahoo, as we all know, right? starting in 2006, we started building these systems at Yahoo. Within a few years, a lot of the other Valley companies picked up Hadoop, and we were seeing similar systems built at all the other Valley majors. And then a set of service providers came in and helped take Hadoop to the wider enterprise, which gets us to where we are today with a very large Hadoop ecosystem. So although Hadoop added a tremendous amount of value in these kinds of analytics and applications, there were challenges. Taking the Yahoo example, it's great to know that somebody was interested in autos 5 minutes ago. But what we really want to know is understand their interest between when they visit Yahoo and their next page view. Because if you know nearly instantly that they're planning a vacation, you can, it's easy enough to know. So if you know they're planning a vacation now, you can serve them content that's relevant to planning a vacation now. If you know they were planning a vacation 5-10 minutes ago, maybe they're doing something entirely different, and they'll see you giving them vacation results now as just a distraction. So there's economic value and user value in tightening that loop and going from insight to action within a second by the next time they click. So we did a lot of work sort of outside that Hadoop processing loop to make that happen, building sort of special purpose servers that watched the logs and looked for the sort of most frequent, most valuable cases and said, okay, this looks like somebody we should be serving vacation planning content to now, auto planning content now. So that was a lot of work because, a lot of sort of special cases and new frameworks built on the side of Hadoop to try to answer that. But again, the economic value was huge, and it was a big incentive. So we did that. Lots of people did that. We started to see sort of first-generation streaming frameworks evolve to try to help with that. Things like Spark and earlier things, S4 from Yahoo. I said Spark. What I meant was Storm. So a lot of value from those things. And that gets us to the streaming era, right? As I said, there's huge value in moving from insight to action in sort of, let's say, sub-second, right? It's, like I said, it's great to know that a user was interested in planning a vacation 15 minutes ago, but now he's moved on, right? In some businesses, it's even much more compelling. It's great to know that your bank has been defrauded and what the patterns are, your financial institution, right? That can help you not be defrauded in the future. But how much better is it to recognize that you're about to be defrauded and cancel that transaction, right? The value there is pretty obvious. Similarly, it's great to know why machines are failing. It's better to know that your machines will fail if you don't service them, all right? Or at least shut them down before the parts start to fly. So insight, the faster you get to insight in many domains, the better. So why has it taken 10 years and more since Hadoop sort of exploded onto the scene to accelerate this learning loop? The reason is, of course, that this kind of continuous high-volume streaming is very difficult. All right. If you're dealing in some of these use cases, you're dealing with millions of events per second. That's huge. So that means you're going to have to throw lots of machines at the problem. And if your framework isn't very efficient, you're going to have to throw orders of magnitudes more machines at it. So you need to have very, very efficient software. Further, if you're throwing lots of machines at this problem, machines are going to fail, as we discussed before. So you need to have a framework that will continue to operate in the face of machines failing. Otherwise, it's just not a reliable system. So further, a lot of these earlier solutions were inaccurate. All right, you would have events just be lost. You would replay events in the case of failure. You just had lots of fuzzy accounting, and all of that was left to the user of the first-generation frameworks or the developers of this ad hoc logic. So in some cases, the value is high enough that it made sense to do that, but it's just complexity. We saw some best practices evolve around this, such as the Lambda architecture. Do it once to be fast, and then do it again with a reliable system to be right? Again, complexity, cost. So when you look at all of that, it would take a team of specialists working together to actually build one of these streaming solutions. And that would really limit the sort of time and cost of deploying something like this, limited where these sorts of solutions were built to some of the most valuable and biggest use cases where you had the largest, most expert teams. So that gets us to where we are today. We've been working with these problems as a community now for a decade and more. And the great news is that the sort of platform we've been building on hasn't been static. All of this learning has been rolled back into Hadoop and related platforms. So two changes that I really want to call out. Well, sort of looking at the big picture, you see that instead of this ad hoc thing in the middle, we've added a whole new layer, which is the streaming layer. So now we have reliable message buses, such as Kafka and Kinesis, that let us guarantee that we don't lose events that are sent towards the system. So that's a big step in the right direction. That lets us consume events reliably while we stream, and also get the same events down into the batch system for later analysis. And we've also added Yarn, which is kind of shown, which surrounds a lot of this. Yarn gives, first generation Hadoop had a storage layer, HDFS, and it had one processing engine, MapReduce. That was very limiting. So back when we were re-engineering Hadoop 2.0, Yarn was really the focus. Let's make it so that we can have not one processing engine, but user-deployable processing engines. And there's two goals there. One was, of course, to give users more options. And the other was, let's let those engines evolve much more quickly. It's incredibly painful to upgrade a production system if you've got real workloads running on Hadoop. In some cases, thousands of active users running mission-critical jobs on the Yahoo clusters, for example. But if you have user-deployable programming models, then you can deploy improvements every day, every week, and the users who need those improvements can deploy those. So as a result, the programming models on Hadoop have evolved much more quickly since the introduction of Yarn. And Yarn also takes a lot of the heavy lifting off of those programming models. Yarn answers a lot of the questions about how you handle failures, and lets the next level platform designers who are building the streaming engines focus on their specialty. So as a result of that, here we are today. We have a collection of streaming engines to choose from that incorporate a lot of that learning and make it much easier to develop streaming applications. So why is Apex particularly interesting? So first off, Apex leverages all of that learning in the Hadoop ecosystem from the last decade. It doesn't reinvent the wheel. It relies on Yarn and HDFS and Kafka to do their jobs, and focuses on delivering really correct, high-volume streaming. A lot of these other engines try to take on more responsibilities. They try to do things other than streaming. Apex is focused. Also, DataTorrent really understands this problem. DataTorrent, of course, being one of the major contributors to the Apache ecosystem, the Apache Apex ecosystem. So these guys come to the problem with years of experience, not only from building and supporting Hadoop at Yahoo, but also Yahoo Finance, where they were dealing with some of the biggest streaming architectures and stream processing problems, all the financial tick data as every exchange in the universe trades. They were doing this in the 90s. So decades before most other people were thinking about streaming, they were learning the lessons about what was hard, what not to do. And further, they're focused exclusively on streaming. It's all they do. And finally, those decades of experiencing actually running streaming applications at scale caused them to focus uniquely on providing a sort of full life cycle solution. Right? It's great to have rapid development, but you also need test and debug, monitoring, and deployment to support an ecosystem of large-scale streaming jobs. So, zooming out a bit, Apex now has a lot of users, and we have their feedback to consider as well. Right? One thing we're hearing loud and clear is that Apex is a platform that Java devs get productive on very quickly. Right? They don't have to learn new languages, new paradigms. They can write the application-specific logic. They can focus on the application-specific logic that they want to write, and they can leverage that large library of tested operators and templates to do a lot of the heavy lifting. And of course, it does have the GUIs monitoring the mature operations tools to get you beyond development to actual production. So great user feedback. And talking about user feedback, right, it has been in very large-scale production use cases since 2014. Right, and this isn't some of the big logos are there, some of them aren't. But some really impressive use cases. And not only have companies been using it now for several years, but the companies that have been using it with DataTorrent have been renewing and expanding the use cases. They came in and did one thing, it worked, and we've seen a pattern of them doing more over time. So that's very reassuring. And of course, the user community has now grown to over 55,000 registered users in just the year since Apex became a top-level Apache project. So lots of positive signal there. All right, so we've talked about the life cycles. We've talked about how we got here, but of course, a lot of the people that are actually using Apex are here today, so there's a unique opportunity for you guys to actually talk to each other and find out what is working and what you are building. So let me encourage you to do that.